Today we're going to be reviewing the Practice Exam 3. So for this section, it says to simplify each expression, do not leave negative exponents in the answer. Now if you look at numbers 1 through 3, you'll notice that they look very similar. Each of them have a 3 base, a 2 in the exponent, and a negative somewhere. So what these first 3 questions are really testing is to see if you understand what the negative means in each place. So number 1, we have negative 3 squared. Now PEMDAS says we need to take care of exponents before multiply. So whenever there's a negative out in front, not up in the parentheses like number 2, but just way out in front, what this means is the opposite of 3 squared. Or almost like, if you want to think about it, like negative 1 times 3 squared. So you're taking the 3 squared, which is 3 times 3, and then you're just slapping a negative on the front. So if you ever have a negative up in the front, I like this problem because I already know the answer is just going to be negative. So all I got to do is 3 squared, which is 9, and then the answer is going to be negative 9. So I like number 1. Number 2 is a little tricky, but students actually like that one better. Negative 3 is in the parentheses, and it's being squared. So what is being squared? Everything in the parentheses. On number 1, what is being squared? The thing right before the 2 is only the 3, not the negative. So on number 2, we actually have to take negative 3 times itself, and that gets negative times a negative, which is a positive 9. So on number 2, when there's a negative inside the parentheses, you have to be careful. If you have 3 negatives, it turns out to be negative. If there's 4 copies of negatives, it turns out to be positive. So depending on if the exponent is even or odd, you might have a positive or negative. Whereas number 1, I don't care what the exponent is, even or odd. If there's a negative out front, the answer is just going to be negative. Alright, how about when there's a negative up in the exponent? Well, then when there's a negative up in the exponent, that means he's not happy where he's living. He's living in the numerator, so he's going to move to the denominator, and now he's happy where he's living. So we have 1 over 3 squared, that's the rule, and then 1/9. So each time the negative does something very different. I can guarantee you that you're going to need to know what these 3 on the exam. Okay, so make sure you are studying up what happens when there's a negative and where. On number 4, we have another negative exponent. We have 3 bases of 3. Now you just can't add those exponents. That's not allowed. But each one of them we're going to evaluate by itself. Anything to the 0, well, that's just 1. Anything to the negative 1, that's 1 over the base. And then 3 to the 1, or just 3, is just normal. So there was 2 rules here. The rule x to the 0 is 1, and then the other rule is x to the negative 1 is 1 over x. So those are the 2 rules that we applied. Now we're going to have to add these, so I'm going to get a common denominator. The first and the third number have denominators of 1, so my LCD is 3. So on the first one I can multiply by 3, so that's 3/3. On the second one I already have a 3, so I'm just going to multiply by 1, or basically just keep it the same. On the third one I have a 1 in the bottom, I want a 3, so I have to multiply the top and the bottom both by 3. Oops. That's 9. So 3/3 plus 1/3 plus 9/3. Now that I'll have the common denominator, which is 3, now all I have to do is add the numerator. So 9 plus 1 plus 3 is 13. So 13/3 is my answer. On the next section, it says to simplify. So each one of these you have to factor first. So let's put a little note here. I can't start just canceling something in the top with something in the bottom before factoring. You have to factor first. A common mistake, don't write this down, but a common mistake is students will go, oh, x and x, that's gone. Oh, you cannot do that. The reason you cannot do that is because the sign here is subtract. What's the opposite of subtract? Well, not divide. So something that is being added and subtracted can't undo itself by dividing. That doesn't make sense. So what we're going to do is we're going to factor. When we turn it into a factored form, then the operation there is multiply, and the opposite of multiply is then divide, which is why we have to factor first. Now the first one seems very simple, but there is a little trick to this one. And the trick is that the 6 minus x is in the wrong order compared to x minus 6. You see on the bottom we have x's in the front and the top we have a number in the front? So what I'm going to do is I'm going to take one step to put the negative x in front and the positive 6 in back. Notice the sign of the x stayed the same. It was negative in the original problem, and then when I moved it, it was still negative. Okay, this is going to help me when I factor. So now I can factor a negative 1 out of the numerator, which is x minus 6. Now the numerator and the denominator have a multiply. There's a multiply right here in the numerator. So the opposite of multiply is divide, and so that whole factor can divide out. Not a part with a part, but the whole factor can divide out. And now we have just negative 1 as the answer. All right, let's do it again. On the next one, we have 4x squared plus 29x plus 45 all over 8x squared minus 10x minus 63. So that means I'm going to have to factor the top and factor the bottom and then see if anything divides out. So I'm going to guess and check. You could group or AC method if you want. I'm going to try, let's try 2 and 2 and 5 and 9 and see if that works. So when I multiply across, I'm getting 10x and 18x. Can 10 and 18 add to 29? Ooh, so close. 10 plus 18 is 28, not 29. So let's try 4x and 1x with 5 and 9. So that gets me 36 and 5. Let's flip those around maybe. Okay, what about if I put the 4 next to the 9? So that's 20 and 9, and that will add to 29 with both positives. So the numerator factors into 4x plus 9 and x plus 5. Now the operation between those two parentheses is multiply. So if I can get the bottom to factor, then these things are going to reduce out nicely for me. So in the bottom, I'm going to try, let's see, 1 and 8, 2 and 4, 1 and 63, 3 and 21, or 7 and 9. Okay, so I'm going to try 2 and 4. And just looking ahead, do you see how the 4 and the 9 are next to each other? Let's try the 4 and the 9 next to each other here. I'm not sure it's going to work, but I'm trying to see if I can't get it to divide out nicely. So I have 28 and 8. And yes, if one's positive, one's negative, I need a negative on the 28 to get to a negative 10. And so I cheated a little bit. I looked at what I was trying to cancel with, and I guessed that one first just to see if I could cancel that quickly. Alright, so these two divide out, 4x plus 9 and 4x plus 9. Because the operation between the two parentheses is multiply, I can cancel the entire parentheses. Then I have x minus 5 over 2x minus 7. And that's it. Now, if you are tempted to try to cancel one of the x's with one of the x's, which is a big fat no-no, but if you're thinking, well, maybe I can, you might want to consider keeping your parentheses. They're not needed, but if you're one bit to be tempted to try to cancel something out, you might as well leave them there to help you remember that you can't cancel those out. Alright, one more reduce problem. So again, the a squared and the 1 is in opposite orders, so I'm going to rearrange that to be negative a squared plus 1. Notice I didn't change anyone's sign, all I did is I reordered. Then I can factor a negative 1 out of the top. We never have the first leading coefficient of a factor problem being negative because I can always just factor the negative out. And that factors to a plus 1, a minus 1 in the top with a negative 1. And in the bottom, I'm looking for two numbers that multiply to 1 but add to negative 2. And I think that's negative 1 and negative 1. Okay, so what cancels? And one factor of a minus 1 with one factor in the bottom of a minus 1. Now I know there's two, but you can only factor one of them out. How about a plus 1 and a minus 1? Are those the same? No, they're not exactly the same. And somebody's going to say, well, what if you distribute the negative? Is that going to make them the same? The answer is no. If they're not going to be the same when they're bifactored, distributing isn't really going to help to make them any different.